Hello everyone. Can you please confirm is my screen visible or the stream has started in the comment section? You can post anything in the comment section. And hello, sir.
Hi, Manik.
Can you please confirm? Am I audible?
Yes, you are audible. Am I audible?
Yes, wonderful. Okay, just give me a second. Okay, now you are able to see the comments in the right hand side. Now these are the live comments, sir. Anybody can interact with us and can ask questions. We can
Okay.
see this here. And if we wanted to share the screen, there is a button just on the right side of camera. We can just click on that and share a screen. Okay. And yeah, let me check if the stream is live. Yes, the stream is live and it will be recorded. Post the session, we can share this stream to all our community members so that those who are not able to watch it live, they can watch it. Okay, sir?
Got it. Got it. Awesome. So it is live now?
Okay. So the flow of the session would be everyone. Yeah. We'll be having an introduction of our amazing speaker, and then our speaker would share about his journey, and then we can start the session. Obviously, be ready with all the doubts, all the questions, all the queries that you have regarding machine learning or how to crack rules in machine learning, and we'll clear them all. And without further ado, let me introduce our amazing speaker, and yeah, obviously, we'll be starting the session. So first of all, we are really honored to welcome Mr. Suendu, a senior ML engineer at Amazon, ex HBO Max AWS, as the mentor for our advanced track of our ML cohort, and he'll be taking our very first lecture of the week one of our cohort. With over 14 years of experience in machine learning, 14 years of experience. MLOps, Cloud AI. Mr. Suvendu brings deep expertise in designing scalable ML architectures, optimizing AI infrastructure, and deploying end-to-end MLOps pipelines. His work spans deep learning, generative AI, distributed training, and cloud-native machine learning solutions, helping enterprises accelerate AI adoption and operational efficiency. First of all, I would like to thank you, Suvendu sir, on the behalf of our entire community for sparing the time and for believing in our cause and for accepting our invitation. So now we can start the session with your introduction. You can introduce yourself and you can share your journey, like from being a student to a senior ML engineer at Amazon, all the experiences that you have gathered over the years. And then we can officially start the session with you explaining the very complex topics of ML in a simple and easy manner.
Sure. Yeah. Thank you, Manik. Yeah, I'll first of all think I'll like to thank you, the Girls Leading Tech community for inviting me here. And I know, I love to contribute to this community. So I want to share my journey or the learnings that I have acquired over the period. I'd love to share here, and happy to clarify, or if you are wants to pursue on this machine learning journey, I'm happy to help you on this route. So about me, yeah, as Manik mentioned, right, I'm currently based in the US. So I am based out basically Arlington. It's near to DC. So I work for Amazon almost like close to 3.5 years, and I do have almost experience of close to 15 years of experience on industry experience. And yeah, so here at Amazon, the team that I'm working with, so although I have hold various positions here, but right now I'm working on mostly on the devices. If I'll just I'll tell you in short, uh, the Amazon devices is the division which is basically leading your Alexa, Kindle, Ring, right, Fire TV, tablets, Amazon owns, right? I belongs to that division, and I work for that data science division. Although I don't want to go deeper in terms of what exactly I do here, what projects that I work. Unfortunately, I cannot share much details here, but so I work on the data science field basically. And prior to that, I was with um, HBO Max. HBO Max is a streaming platform. It's a very much popular in the US, like Netflix. And I was working on the content intelligence side, basically, and the subscription side. So there, I worked in terms of, you can think of when you are subscribing to a Netflix, or you are streaming any content on the Netflix, then the next moment you will be seeing some recommendation to you, right? You are seeing some hey, this content is meant for you. Why don't you watch it? Or there you will be seeing plenty much of recommendations. So I work on those lines of business. So basically, in the data science business, basically. So how the recommendation engine works in the real time, how the streaming system works end to end in terms of when you are watching a movie to the next recommendation thing coming to your screen. So that area I was working on. And prior to that, I was a staff engineer with Equinix, is a data center company basically, and I was based out from Singapore. And there I worked almost 5 years, and I was leading a couple of initiatives on the data and machine learning field for the predictive maintenance on the electrical mechanical devices. So how exactly automatically will detect when this machine will be need uh, your next maintenance before it is breakdowns, basically based on your features, and your machine learning models will predict that. And a couple of other um, um, pro- machine learning models that I have developed and lead there. uh, in nutshell, I'll say my my journey has been I'm not traditionally trained. So I'm not traditionally trained during my college days. There was no concept of machine learning, although it was there, but it was not too much available to us in terms of when we started like you know at our college. Now the things are you've been lucky enough right now to have all these mediums where you can learn, and you can know the leading technologies. But the time that I just done my graduation or master, that time we have a limited access to the internet, or limited access to the information, or the machine learning was not that set of boom, and it was not part of the curriculum. So the journey has been I started as a software engineer, a traditional software engineer, writing on the code on the Python, Java, not even Python, Java, purely Java, right? Then I the journey has been basically is very uh, difficult, I can say, but it is good way difficult, uh, right? And it is pretty much interesting as well. So how I shifted my journey from a software engineer to a machine learning engineer, and also some extent of the perspective of the data as well. How I learned it, I'll share it with you all. So yeah, further to you, I'll just stop here right now. I'll ask Manik to give me so tell me how you want to proceed, Manik. So in terms of do you want me to start with the course today, in terms of the machine learning course, or do you want me to proceed with uh my journey? How do you like to do that?
Yes, sir, definitely. We can first of all proceed with your journey. Then with the course, obviously we'll be covering the topics like real world machine learning life cycles, data pipelines, train test leakage prevention models, and feature engineering, encoding, binding, all the topics we have in the bucket for our lovely audience. But uh, I'm very curious to know, sir, back then in your college days, when the concept of machine learning and artificial intelligence is not that much in hype, so how you got to know and got to transition from software engineer to machine learning engineer, and from India to abroad to working at so many places? Because after all, after getting knowledge out of this session, all the attendees, all the audience that are here in the session would like to target any roles at a very good companies, or maybe there is a conception that if you really want to have a leadership position or a higher position at a very good company like Amazon, Google, or there are a lot out there at a higher position, so we need masters or a PhD. So is it true, or like what are your viewpoints on this? Then after like 4 to 5 minutes later on, we can start the coursework.
Absolutely. Yeah.
Okay.
So, yeah, sure. I love to like share my journey. So yeah, as I mentioned, uh, I started as a software engineer till 2000. I can say uh, 15 to 15 actually. Yes. So on 2015, I'll say you like it's a very very good story. So I was based on like India, and I was working for a MNC. Basically, it's a good like as a working as a mostly on a Java developer, traditional Java developer, and suddenly I came across a very fishy kind of job post. Hey, you can work remotely, right? In a US company, right? It looks like it's a kind of like suspicious, like nobody pays you in USD when you stay in India, right? So that's back in 2015. Nobody the remote job concept was not that much popular. So fortunately, I went ahead and just applied that role basically, right, into that company. And that company was based out in the US. And I just remotely applied to it, that role. And somehow I went ahead with the flow of interview process, although the interview process was really tough and it was little difficult. And I went ahead with this process, and luckily on a good day, I got to notification that, hey, we want to offer you a job, right? And that was a remote job, and that was basically best out the company was best out from US. And and you will be getting as a big exposure, the good take. And I was working in India, but I got exposure to US tech basically. It's a big thing. So I don't have to come to US, but I can work. So then I went out with the company, and I started joining that company, and I started working remotely, and that's where my machine learning journey started. So that company was building out a very much advanced system, which can basically detect the whenever you're working remotely, any person working remotely, that software will be able to detect whether the person is basically concentrating on working or not, or distraction levels and all. And by the analyzing the videos, images, and analyzing their activities on the wave or the laptop basically. So that's my first step. I was not trained in I joined them as a Java developer. Then I got the opportunity there to know basically a data science problem, right? What is this data science problem, how they solve it? Although I was not building it, but I got interacted with that problem basically, right? How they are detecting from an image whether the person is basically a focused or not, right? Based on the activities from their keyboard, mouse, and other activities, how it is basically they're detecting the person is basically productive or not, right? It's a traditionally you cannot solve using a traditional algorithm. You need a that's kind of basically machine learning can solve it. So then I joined, my machine learning journey started, and I started loving it, because this is a very much problem that this is a problem that I've never seen it or never solved it, right? So I was traditionally, like, solving the problems using the APIs, or pulling out the data from a database. So that's where my journey started. I started learning, like, machine learning. Then I invested time in terms of, like, learning the concept of it, learning, like, the how to process an image, how to process the data on the machine learning, and so on. And I never stopped from there. I started, like, then I that opportunity basically bring me to the a global scale, basically. That opened my, like, way to Singapore. And I worked from Singapore as a very leading tech company. And I was able to, like, work on very leading technologies as well. And machine learning, data, those lineup, like, technologies I was able to work. Then that led to my path to a better company in US. And I joined Amazon. And definitely Amazon journey is not very easy. Although even though you do have a strong knowledge in machine learning, or you are, like, you skilled yourself, upskilled yourself into the tech. Not about, like, only machine learning, any tech basically you are working on. If you have upskilled yourself already, but getting into a big tech need little bit of dedication in terms of the preparation of their interview process, because their interview process is very stringent. And they do have a very like, need a dedication preparation in terms of your algorithm, basic algorithm setup, algorithms, and your system design, or your specific specialty, like, the area that where you are applying for, right? So that preparation, like, helped me to get into this Amazon. So I can say, like, yeah, the journey is like, although I skipped, I have, like, uh what I can say, basically this is the abstract of my journey. It is not a detail of journey. If anyone, like, love to work, wants to, like, know detail, just to, like, happy to connect over the LinkedIn, and just, I can guide you how you can uh prepare, or how you can, like, lead your path where you want to be. Yeah.
Wonderful.
Over to you, Vinny.
Wonderful, sir. Amazing. It's an amazing journey from India to Singapore and to Amazon. Now that would give a lot of confidence to our attendees, and they can also feel like, okay, if Suvendu sir can go from India to Amazon, we can also go. And obviously, with this
Absolutely.
session and your knowledge and your insights, we can definitely do much better. So yes, sir, we can start with the coursework. Like you can explain the concepts and topics. Uh, as per you, like if you want to share your screen, or want to present a PPT, or want to share just verbally, or want to showcase the practicals things live by sharing your screen, we can have it all as per your convenience and as you like it.
Yeah, I would love to, like, we do have tomorrow, we do have a session as well. I'll go very little deeper on this. But I know, like, I'm not pretty sure, like, how the audience will be familiar with machine learning, but I will go over, like, some of the concept of some machine learning on a very easy way. I try to make you understand. Uh, so that's my, like, today's agenda. I'll not go deeper. Tomorrow maybe I'll go deeper, but I'll start with, like, very basic of, like, of machine learning concepts, some of the concepts that everybody should know that, right? Then we can go deeper, because yeah, so that's my plan basically. Do you, is that fine for you?
Yes, sir. Actually, we have different sessions divided as per the topic. So most of the basic concepts have been covered yesterday. So we can go to the deeper level if possible. Yeah.
Okay, sure. Okay. I'll try to basically go into the, like, some of the concept of machine learning. Then we can go into the deeper level, and I can talk through some of the prompts basically, right? While I'm just, like, presenting. Uh, let's think about, like, a Okay. So if the audience is already know about, like, what the machine learning is, I just want to go over, like, a basic set of things basically. Late for example, uh as I mentioned, like, from my real time experience, I just, you can see my, so before doing that, can you see my screen?
Yes, yes, your screen is visible, sir. Perfect.
Okay, awesome, cool.
Cool.
So this is a website I follow a lot. This I can share that later. So this website, I love it. If you are starting with, like, machine learning, you are very beginner of it, and this website will give you very interactive way to learn the concept of the machine learning, which I followed. And it's old school, but I still, like, love this, and I learned from this website basically the concepts. And so as I mentioned, like, coming back to the session that I was talking about, let's think about, like, why I need the machine learning, right? So as I mentioned, I was working on the first time whenever I interacted with a machine learning problem, that was like, uh, my company was, like, developing a system, or a app, which was basically taking the, like, taking the pictures or the videos, and like, analyzing the keyboard mouse movement of a laptop of a remote engineer who is working for a company, and based on that, their movement, or based on their activities, it will be detect, like, hey, this person is productive or not, whether we should bill for that particular hour or not. For example, if you are in office hours, someone is basically watching a YouTube video which is, like, out of scope, or it is not related to the work, uh, we can identify, like, hey, this billing, this hour is not, like, billable, right? So think about, there are lots of, like, integrity of a problem basically, right? So if a problem is very much complex, and there are multiple dimension to it, right, and there are lots of variables to it, and which we cannot achieve using a standard set of algorithm, right? So because even though we try to like, achieve it, you will be end up writing, like, multiple syntaxes, multiple, like, conditions, where you will be writing, like, hey, if this is happens, then this will be the path, this will be the result. So if this happens, then this will be result. If you will be, like, you are keep on writing, you will be having, like, millions of combinations of, like, prompts, and millions of conditions that you have to write on your algorithm, and that technically is not going to, like, scalable. It is not scalable prompt. So that's why your machine learning comes in. The machine learning is kind of, like, helping you to using a statistical way, or mathematical way, and combination of the computer science basically, right? It's a statistical and plus computer science, you are solving it, right? So for example, I'll give you, like, here example. Let For example, I'm writing five here, right? A handwritten, like, number, all right? And I want to detect it using my machine learning. So technically, like, if I'll be standard algorithm, if I'll write, then maybe it will be very difficult for me to do that, because in a pixel level, I will take this image, I'll check on the each pixel level, and I compare with, like, same another number and pixels, and I'll see, like, if that pixel is matching, then I'll be making that I'll give my result back. But if I'll be, like, for example, I'll change this pipe into like this, or something like this, right? So then the pixel is getting changed, right? So in a machine learning prompt, so doing a different variety basically. Earlier there was a bigger one, it is smaller one. The earlier one, like, this one is very different. So all this modality or the dimension of the prompts are really, like, uh, very much, like, the dimensions are multi-dimension, the prompts are multi-dimension. and the attributes are multi-dimensional. In that case, like, how you can automatically solve it, that's where the machine learning will come in. Okay, in further ado, let's like, move on to a little further in terms of, like, technically, in a nutshell, in a real world, how the machine learning actually, like, a prompt, basically, as a machine learning engineer, how we solve the problem, right? you must be you must be, like, learn from the many web content, or any of the uh, like, uh, any of the, like, articles, that how exactly, what is the life cycle of a machine learning model. So this is, like, you must have seen, right, 5 simple steps to build a model. So you must have already seen this, but is it actually practically, is that the same thing that we do apply on a real world, or real world machine learning model? Technically, like, yes, we do that, but the differentials, like, when you will come to a real world of building a machine learning model, or a like, actual problem that when you are trying to solve, so you will be having a like, different, like, a a problem that you will face. So different problem in terms of, like, different set of problems that you will face. The first problem is basically uh the where you will be, basically, the first thing is basically identifying the problem, right? So as I mentioned, like, so whenever a project kickstart, whenever you will be working on a machine learning model, so the first thing that you will be identifying, like, wait, what I am trying to solve here. And sometimes the prompts are very much ambiguous in nature. It is not pretty much clear, right? So, Ajay, one thing that you should keep in mind, when in a real world, when you are solving, you will not have a clear statement. Very much often, you don't have any clear statement that what exactly and how exactly you are trying to solve. You will have a very much, like, very ambiguous prompt statement that you will need to solve it, and which is not even solved till now. It is a new to you, right? And and s- and what you need to do is basically, let for example, I'll give you a very much like, real time example, so which you can relate. Let for example, I'm working with Amazon, right? And I'm a seller, right? I sell the product, and Amazon has the portal where Amazon, like, I will be selling my product. Let for example, so Amazon provides you a seller portal where you will be adding your product, you will be, like, featuring your product. Let you want to sell, like, your t-shirts. You are selling a t-shirt, t-shirts or pants, or any like, garments that you want to sell it. So in that case, like, you do have a like, website where you it is called a seller portal, where a seller will be going and just adding a, like, product, like, hey, I want to sell this t-shirt, and I just want to, like, sell to on the Amazon portal. Now what happens, like, as a seller, think about basic thing. Basically, a seller comes in, like, adds a product into the your seller portal, and upload some of the images, or some description, or some videos, and they click, like, hey, publish, or push that. Now behind the scene, like, as an Amazon engineer, let's think about this. You are an Amazon engineer, and someone basically is selling a t-shirt, but they, on the pictures, they have added, like, a gun, or they have added, like, a gun picture, or instead of, like, t-shirt picture, they have description is t-shirt, but they have added a gun picture, or any, like, on, like, allowed, or which is basically the picture is not allowed to the portal to sell it, or some of the product which is not allowed to sell it. They'll be starting, like, uploading that picture to sell it, or they'll be adding some mobile number into this. Now as a machine learn as an engineer, you need to think like, how I should prevent it, right? How I can prevent it so that it will not come to my, like, whenever the seller, they can add anything. But as a on a prevention mechanism before it goes air and goes, like, to the Amazon.com portal for selling the product, I should make sure that it will be goes through all the thorough checks and all the integrity checks in terms of, like, this product is valid or not, and also the, like, the images or the videos that has been added are valid or not, or it is acceptable or not. This is the prompt statement. It is like, you will get this kind of prompt statement. And then, like, hey, how you will do it, you don't know it. So now second page is basically, this is like, prompt statement. This will be, you will get, like, hey, this is like, prompt statement, now solve it. The second step is basically, as I mentioned, like, the number one step is, like, import and inspect data, right? So now I do have a prompt statement. Now the thing is how I will solve it. So machine learning, if you know it already, so machine learning all about is the data, right? So for example, I'll go back to my uh the node that I always follow, and which is basically like, easy to make you understand. So basically, like, for example, this is a machine learning problem that where I need to identify, like, whether it is a apple or banana, right? So there is a machine learning model which identify, like, it is apple or banana. So same way, let's think about, like, you have given an image, and on that image your description says it should need to be a t-shirt, but if it is not a t-shirt, it is, like, something else which is not acceptable one, and which is, like, not a allowed list, not allowed list. Basically, how you'll identify this? So to do that, you need, like, set of, like, a examples. Basically, you need a t-shirt photo, and also you need a gun photo, right? Or a arm photo, basically, or a non-allowed product photo as well. So this is called your, like, input set of the data. In a real world, what happens basically, um, when we start a project, we make sure that we should, like, the first point is basically getting the data, and where we interact with it, like, our data engineers, like, help us in terms of, like, getting the data, right set of the data for us to explore, analyze the problem, basically what we are trying to solve. So mostly we work with, like, our data engineering team, and the data engineering team mostly, like, helps us in terms of, like, getting the right set of the data to us. And the data could be, the medium could be, like, anyway, I'll go to that, basically how what happens basically on the data, how we access the data. But the first page is basically collecting the data. So the data could be, like, the images of the different, like, products, and the different product, like, the category, it is allowed list, non-allowed list, right? And the description about that, and the metadata about that, those, like, images. So we collect those first, right? So now think of that. Yeah, I'll go back to the slide again. So a second step is called a selecting a useful feature, right? So that is technically we call is feature engineering. So I'd say we spend almost like 60 to 70% of our time in terms of this page, right? Practically, like, we spend almost like I can say, like, it depends on, like, project to project basis, it is not generalized. But my aspect of it called, like, I spend a lot of time in terms of selecting the right set of feature for my machine learning model before it developing it, right? So what exactly the feature engineering is? So you must be heard about this, like, term, that is feature engineering. So feature engineering kind of, like, in a simplified way, if you know it already, that is good. If you don't know, then I'll just, like, explain you this. Like, for example, here, right? This is apple photo, basically, and this is a banana photo. And uh, here I'll be seeing like how I'll be identifying a apple. There is a apple width and apple height. So this is like two of the feature. That means how we'll be identifying a human. Human is basically we have eyes, we have nose, and we have like face, and we have like two hand, two leg. Those are like features of some like some object. Same way apple is having some feature, and banana is also having some features. So banana is having like width, height. Same way apple is having the width and height, and banana and apple and how the machine will be like learning is based on their different features and characteristics, and machine learning models, whichever the model that you will choose, then that will basically learn from those features that you fit in. Now, a a gold statement always you must be heard, that is machine learning is a concept where you will be garbage in, garbage out, right? Garbage in, garbage is out means, if I'll simplify this statement, garbage in, garbage out. So let's think about, if I will not spend enough time in terms of analyzing my prompt, analyzing like what is the right set of the features that I will be put into my like model for training, if I'll not do that, then I am putting some of the garbage, right? And there is output from that like bad features or the bad data result in a bad model or bad output, right? So even though you do have a very much uh, uh, advanced algorithm, it's a very much like great algorithm that you're using, part of like for training, or the methods that you are using to train. But still like if you're not right set up the data you are choosing, then you are not in a right track. So my suggestion is, spend a lot of time in terms of learning the feature engineering steps, the feature engineering right set of like features that you should choose for your model. So this, the collecting the data and doing the feature engineering is very much essential here. Now, if you ask me like on the feature engineering, what do we do, what do we basically how we do it. So basically we connect to the a, as I mentioned like some time back, the we work closely with the data engineering team, right? And the data engineering team provides the data in forms of um, in a data lake. That means you will be, if you know, first time you heard like data lake concept, then it is a big thing. But think that if I'll simplify, basically where all set up like the big data reside on a storage, mostly like we can concept like we can take any storage, but I was mostly work with the S3 basically, right? On top of the S3 storage, we do have a wrapper which will make the data access easy. So what I do here is I connect. I do have the your ID where basically you can like take any Python ID, or you can like any of the data science like ID, where you can connect to the your from your ID to your data set and access that data to your ID and explore it. That is called like your data exploration and feature exploration. Basically you will learn about like what exactly the data that you have received from the your data team, and what exactly the features you have, or do you need like certain features that is missing right now. And you can put a request to the data team like hey, how I can get this features, right? How I can get this data. This is not a feature, they will not mostly provide the feature, they will provide you with the raw data. And your job is to identify like what are the set of like data that you have received, like it is sufficient or not, or you are missing some data. So you go back and forth with the data engineering team in terms of like getting that done. And now second aspect of it, basically once you let, for example, you do have the right set of the data, the next setup like go to the feature engineering. Feature engineering, you will have like the tools available, widely available tools, like which helps you in terms of like analyzing the your features and in a very much graphical way. or you'll be using the Python libraries basically to analyze that data. So mostly the Python libraries that we use here is Python, like standard libraries, basically matplotlib, basically to plot the and visualize the data basically. And in addition to that, we use like NumPy, pandas for analyzing the data on a big scale. So you need to learn basically NumPy, pandas. Those are like very much handy packages of Python which help you in terms of analyzing the data. And that's what we do. And in addition to that, many org use like as a professionally you will be using like uh, advanced like Python libraries for better analysis basically. And in addition to that, in this today world, mostly the analysis is done through automatically. You do have lots of tools that you help with. Like for example, we heavily use on SageMaker, right? I'm SageMaker driven basically. It is need not to be you not to need not to be use the it is not required for you to use the SageMaker, but it depends like which org you are going to work. They will be providing you like right sort of like they do have must have some tools they have adopted, and they will be using like Google Vertex or Vertex AI or like AWS SageMaker, and which will help you to like uh, analyze your data and learn the patterns, which data features that you should choose it. Now, fast tracking my steps. So let me take a pause here. I'll just go back to Manik in terms of like understanding what exactly. Hey, Manik. So
Hello.
yeah, are we in line with this timing, or how you want to process? How much time
Yeah,
we have?
definitely. We can have it like till 9 p.m. Like till
Till nine.
40 minutes more.
40 minutes?
More, yeah, 40 minutes max. We can have.
Okay. Okay. 14
Yeah.
minutes more. Okay. Cool. Cool. Awesome.
40,
Great.
40.
Oh, 40. Okay. Awesome. Great.
Maximum 40
Then we have
minutes.
we have
Yeah.
enough time to me to like go a little deeper in terms of like sharing my experience. I hope this is going to help you, because I don't want to go into the uh, traditional way of like the machine learning concept I was thinking. But since you know it, I would like prefer to say like what exactly in the real world, how exactly the learning models is been developed, right? What are the steps that I believe like that's why I'm sharing it. I hope this will be helpful.
Yeah, that would be great. Like the practical concepts and all the topics
Yes,
that I've shared with you.
sure.
Amazing.
Well,
Cool.
cool. So I'll start sharing my screen again. To Okay, here you go. Okay, correct. Now, once you're like, you have done the feature engineering, you have selected the right set of the features, and like, right set up, like, hey, this is like, the features that I've solved, selected. Now, to train the model, I'll give you a practical example so that you can relate how we solve it in a real world. Uh, I'll go back to the prompt that I was talking about. Think about you have an image, right? Uh, and that is basically my prompt statement was, hey, my business given me like or my PM given me like a prompt like hey, Subendu, you need to solve like the seller are adding the bad images and which is not acceptable to our site, and they're adding it, and you need to prevent it basically before it is going and featuring on our catalog on Amazon.com. Let for this is the prompt statement and how I will solve it. So now I know, like now I got a right set of like data, that is bunch of images, which tells me like hey, this is not acceptable, this is acceptable, this is the image of acceptable image, this is a non-acceptable image. And if I'll go and wants to train my model, like how I will do it, what's set a right set of like uh, your tools or the model or the algorithms that I will choose and how I will solve it. Now, think about this aspect. So the image is kind of a made up of pixels, right? For example, if I'll go this, when I talk about pixels, I'll explain this with an example. Late here, all right, this is a apple basically. If I'm just hovering over it, that you can see there is a, like, on the below it, there is a, like, red, green, you can see this. And in addition to that, in the bottom you can see the basically the values is getting changed. Whenever I'm like, taking hover of it, the values are getting changed as well. So think about, these are the numeric values which identifies a a characteristics of an image. And a machine learning or a machine understands only the numeric values. It doesn't understand the other things. It only understands the numeric values. And based on the numeric values, it performs, like, the statistical analysis or derivatives or linear, or, like, algebras been applied on top of it, on this numeric values, and it identifies, like, pattern out of it, and it learns from those patterns. Now, uh, this is like, I would say, like, there is a term called embeddings, right? What is this embeddings? So embeddings is kind of a, it's a called a feature, right? It's called a feature. Like, for example, I will go back to the example that is called, your apple is having the width and height. Let's think about, there is a, this is a plot. This is like, a x-axis and y-axis, and it is a 2D plot basically. It is a two-dimensional plot, and I have two features basically. One is, like, x is basically height, and like, sorry, yeah, x is height, and your y is width. And on this 2D plot, if I'm having a, like, height is 4, and like, sorry, width is, like, 4, and height is 35, then it will be plotted on this graph. Same way, if each of those, like, items basically, if I'm choosing, it has basically certain features basically. You can see this, right? So those are, this is a called two-dimensional vector space, or equal to two-dimensional, like, embedding space. On this two-dimensional embedding space, I have two features. But when I have a real example, when I have, like, a image, uh, a like, a big complex image, like, for example, a t-shirt, or a, like, a gun, both, or any object basically, which is allowed and non-allowed. So what we do first is we extract out all the features out of it through the vector embedding method, and those embeddings, we store that into a vector database. Okay, so think about, and the dimension is not only two-dimensional. The dimension will be 786, or 1024, or the dimension could be anything basically. It should be, like, bigger dimension. You can think about, like, it's a multi-dimensional space where each of the features will be stored, right? So of a image. And what do? We store all this, like, we take that, the during the data extraction phase, we take that image, we extract out all these features, and we store that into a database. That is called, your vector database is the right setup, like, uh, the right vector, like, database is called vector database, where you will be storing a multi-dimensional data. And multi-dimensional data is having, like, multiple dimensions onto it, and it has, like, almost like 1000. Here it is, you have two dimension basically, two features. It has, like, thousands of features, and those thousands of features will be put that into onto that dimension, and it will be stored onto some, so into the vector database. Now let's think about, like, um think about, I'll shift a little bit of the prompt statement. Let's think about, like, a traditional prompt statement basically. If you would have ever went to the your um, your Google or Facebook, right? When you will be uploading your pictures of your friends, right, with a group of pictures, sorry, group of people, you will be uploading a picture basically. And you will be ever wondered, like, Facebook will show you like, hey, is this your face? It will show you like, tag this face. Automatically, it will detect the face, who he is basically. And it will give you a name basically. Okay, he is X, he is Y, he is Z. How it is doing it, right? It understands it takes the image, it understand like, the pixel wise, and it will match to the existing picture they have, and it's compare the pixel to pixel, and it detects like, hey, this picture, this pixels is matching to this picture, or this is matching to this dimension, and this portion is this, right? And if your the machine is correctly identified, then you will be tagging, okay, this is the person actually, right? You are right, you are tagging it, automatically detecting the features same way. So what we have done is, so we have taken this image, we extracted out the embeddings out of it, and that embeddings basically helped us in terms of like, identifying and store that embeddings into a vector database. And whenever a new picture comes in, let think about like, the non-allowed pictures, basically the non-allowed pictures, we will store it like in a gun is a non-allowed picture. And whenever another picture that seller will be uploading, we take that picture, we extract out the like, embeddings out of it, or the features embedded out of it, and we take that and we compare to on our database, and we match, is it matching to any of the like, non-allowed pictures, non-allowed data sets? Yes, if it is matching, that means this data or this picture is not allowed. It is an invalid, like, image, and you should not allow that goes to the like, Amazon.com. So I'm not pretty sure like, how extent you are understanding these concepts, but I'm trying to like, make it simplify as it possible. But I'll stop share my screen for a while, and I'll bring the practical like, what the things that I'm talking about, I'll bring that so that you can correlate more. I'll take a while. Just allow me a minute. I'll pick one of the practical example to make this more correlate. Okay. um
Sure.
yeah. Here you go. Okay, beautiful. I got a very beautiful um practical like, uh share your screen, and screen I'll share, and I'll, here you go. Awesome. Cool. Let's think about this way, right? So this is the image, right? Some images that you can see. Before I go this, so this is I was talking about. Whenever like, a image is been push, like I do have an example here. Let example, I'm searching for an image, that I'm searching for like, handmade accessories of it, and it is showing the related images, and how it is basically detecting it. I post some of the like, text, and based on the text, it is searching the images. How it is searching it, basically it understanding the, basically the words is converted into the related basically embeddings, and it is searching on the vector embedding space. So what we'll be doing here is, let's think about, if I have a food picture, and this is basically I was talking about the dimensions, like, if a photo like, a people picture, it will be fall into the people dimension. If it is a toy, if it is a toy dimension. If it is a food dimension, food has multiple like, photos, it will be fall into those dimensions. Now if you are giving a image, or you are giving a text, then what will happen is basically it goes and converts that back to the embeddings, and it will be search on the vector embedding space and find out the related relatable images basically. Right now, if I'll tell you how exactly it looks like, see here, a multimodal embedding space, 6 million numeric item. So how exactly it looks like actually in a practical way, how the embedding space looks like. So each of this images will be having uh, it will be placed on a embedding space, and how exactly closely they are related, and based on that the search operation happens basically. This is the practical how the embedding spaces look like. Cool. Now, let's go back to the things that I was talking about, right? So how we solve this problem basically. So now we take the image, we store that into the vector embedding space of that particular image, and we whenever the seller will be adding that image, so what we do is we do the reverse engineering. We take out the on-scene image or the seller added image, and we extract out the embeddings out of it, and we take that embedding and we match that embedding against the your vector embedding space where all your non-allowed images are been stored, and we'll check if that embedding is matching to any of them. And one of the factor that we see, no, sorry, C is basically a technical term, is called your cosine factor. Cosine factor is how relatable, same way the example that I told you in the Facebook, whenever you are uploading a picture, your friend photo is automatically getting detected and the name is coming. How it is doing it? So it is basically it is checking that image pixel against your friend's photo already been stored and already been tagged from his profile, and it's checking okay, how it is, how he is basically closely matching and closely matching, and it is telling you hey, uh, it is your friend, and it is showing automatically the name. Same way basically how it is be basically whenever so what it will do is your friend's image, it has been already stored on the database, and you when you will uploading a photo, it is basically goes and check against that, and it will be seeing how closely, which is basically the images or the faces are closely matching, the embedding space is matching. If it is matching, then it will be giving you a basically suggestion. Okay, this is the person. Same way, so when you will be uploading a t-shirt photo, it will be go and search against our entire database. Is that it the t-shirt photo at the pixels or the embeddings is matching to any of the non-allowed product? If it is not, then it is allowed. It is allowed, it is good. If it is matching to any of the non-allowed product, that means it is not a good one. So then we block it. You got it? So this is basically we have combined a concept is called your multimodality, basically vector search, where we have used your LLM to do that. Right? LLM helps us in terms of creating the your embeddings out of it and embeddings matching basically. Now, coming back to the training of the on a traditional, this is the thing that I talked about. Now, how you will be training the model on this kind of problem. So the training is the model is basically you will be basically creating a uh, ML algorithm, or you have already a ML algorithm, or already embedding algorithm basically. So you will be passing out, you will be providing all these images, the images that you have selected, the non-allowed images. You will be passed through it, and you will be converting the embeddings out of it, and you store that into the vector database during the training page. So what you will be doing is basically you will be picking out the the embedding algorithm, and you will be you can retrain it, you can fine tune it, or you can basically take the algorithm as it is, and you can use that algorithm part of your training code, where you will be passing the data, it will be converting into the embedding, and you store that into a vector database. Right now, The second phase of it, fourth phase of it that you can see is basically the validating the test set. So the validating test set is basically you have done this, but how extend your ML model that you have used is basically impactful or it is accurate. So you need to validate those, basically that model on a test environment or before you are publishing that model to the productionizing it. So that is called your validation. So validation, how you will do it, you do have a you must have know this is a very basic concept of machine learning is basically whenever we're doing it, a machine learning model, we're training it. So I'll go back to the here, and I'll go back to my notes here so that I can explain basically. Okay. um okay. Okay, just allow me a minute. I'm just trying to the right set of uh oops. Okay, I'm trying to pull the right set of mm, nodes. Okay, yeah. So as I mentioned, you have a training data and you have a learning algorithm, and you will be whenever training data will be passed to that through that learning algorithm, then you will be having a model, and this model is been used for your predictions. Now, how I will be knowing this model is good or not? Basically, I need to pass through the some unseen data on which the model has not been trained at, right? If I'll do that, then it will be there is the concept is basically overfitting, all right? Or so the concept you can learn from the basic uh from the basic basically you know uh your machine learning concept. Basically, this is called your overfitting prompt. So basically what you need to do here is basically you need to make sure that underfitting and the overfitting problem will not be there, and it will not be learned from the bad data, and also it has not learned it has not basically overfitted, or neither it is basically your basically it is underfitted. Basically you need to make sure that you need to check it. So to check it, you need to pass the unseen images, the images, for example, any random images which on which the model has not been trained. We pass that image as a test data and to our model on a lower environment, on a dev environment, and we get a result out of it. Basically, what is the accuracy of it? Accuracy is basically precision recall, all this accuracy that we collect, basically how accurately that model is predicting it. Then that basically helped us in terms of basically um, consider whether the model need to be published to the prod or not, right? So I would go back to this again here on the process, and I'll talk about a little bit of some concepts here, right? Now, think about in a real world, you have you if you will be going right now, you will be starting your journey. You must be come across this this 4 page. Basically, this will be very standalone problem. Then you go you create a notebook and you pick up a very traditional prompt, then you start building and starting learning. This is the right path. But in a practical way, whenever you will be working on a industry, then there will be a concept is called your MLOps. What is this MLOps? So MLOps is basically, as a data scientist or a machine learning engineer, I worked on I imported the data. I tested it. I extracted out the feature. I trained the model. Then I validated the model on my notebook, or SageMaker notebook, on a cloud, and any of the portal. So now I know my model is behaving well, but that's not the way that models should go, and we productionize it. What do we do is we do have a process that is called MLOps. MLOps is basically operationalizing your model. Why we do that in a on a practical world? uh, so your machine learning model, uh, the very difficult portion of it is called operationalizing it. Operationalizing has the different component to it. The first component is basically uh, all these things that as a data scientist have done into that notebook, convert that into a automated process, right? Like getting the data, train that model, sorry, do the feature engineering, then train the model, validation that model, then finally deploy that model into the production. It's a big concept, but think of that I'll try to solve, like, put that into a very one frame. So think about, like, I'm writing, like, a software life cycle. How I'm writing software life cycle, the same is the your MLOps life cycle is. So basically, so I'll be writing set of, like, code which will be basically picking out the data from the right side of the data source. Then I'll be that pipeline will be, again, once the data will be available, then it will be passed that into a feature engineering code. Feature engineering code is basically is a Python libraries that I have used to extract out the, like, the features that I already talked about. Then then store that into a feature, like, storage. And we often call this as, like, your feature store. Feature store is, like, the technical term of it. And we do have call it as an online feature store and an offline feature store. And I'll that's a big concept, but I'll just, like, overlook it, and I'll go into the deeper level later. But we store the features into the feature store. Then the second step is basically we connect those features into the model training. And to train the model, we don't train that in a standalone, basically same as your data scientists do. Rather than, we use the containerized, like, for example, Kubernetes. Kubernetes is the one of the, like, containerization method, where we create a, like, a Docker container. And that Docker container will be contains, like, all the necessary Python libraries or the machine learning libraries that was required for you to train your model. We compose that into a bundle, and we push that into the, as a Kubernetes container, and we run that automatically, basically, or as a part of that, like, ML ops life cycle. And that is basically where your CI/CD operations, like, we work closely with the infrastructure engineers, MLOps engineers, infrastructure engineers, and like, SRE engineers, basically, mostly. So they helped us in terms of, like, navigating that entire process. And each of the team has the different MLOps architecture or the framework they adopted. And we mostly, like, work here at Amazon SageMaker or in-house, like, MLOps, uh, your frameworks we have, and that's we use part of, like, our entire, like, your model training. And once the training is done, then the validation step is taken care part of, like, your MLOps itself. So MLOps, basically, there's another step which will be uh, do the validation automatically. Your model has been created, then your model is pushed to the your model registry. Then your model registry stores, like, all your model information. Then your validation done on top of that model that has been created. And it could be possibly, basically, you can do that during that training phase as well, or you can do that using the, like, after the training is done. And and we store the test data set, basically, in a separate feature store, or with the same feature store on a different tag, basically. And we pull that tag or features, and we pass that feature into our train model, and we see how the train model is working on a real world. Is it performing as expected or not, right? So once that is done, then we push that, like, final version. If it is looks good, then we pull out the matrix out of it, and the data scientists and the machine learning engineers validate the matrix. If it is looks good, then what they do is, so basically, we store that back to our model registry. And we once we model will be persisted into the model registry, then it is like, we promote that into the, production phase. And before going to the production phase, the model could be like, different kind again. So it is a very much complex, like, uh, types of model in it. Right now, you must be heard, like, the large language model, traditional, like, deep learning models, or traditional, like, your supervised or unsupervised learning models, right? So depends on type of the model, your infrastructure requirement will be different, or the way you push that into the production are really different, right? So if it is a standard traditional ML model, then what do we do is we basically validate, your data scientist or the machine learning engineer validate, like, the evaluations of the model during this fourth phase, and checks, like, what is the, like, if it is a classification model, basically, what is the, like, FN score, recall score, and what is the, like, AUC score, and based on the score, if it is like, it is above the threshold and it is acceptable as per the business, then what we do is we promote that into the production. And for the production promotion, we don't do that manually. It is a MLOps, like, CI/CD cycle has been written. CI/CD basically, same as, like, you are training your CI/CD, basically text, like, from your model registry, then create a deployment container using the Kubernetes, and it's deploy that model into that Kubernetes environment, right? And during the deployment, the right setup, like, the packages that are required for that model to run, the Python packages, or any, like, sort of, like, environment, a specific environment that is required, that you will be package it out, and it will publish that into the Kubernetes container. So then your model will be there. Now, I just want to highlight, like, the model type, basically, right? There are two or three high level type of models. One is, like, your offline and online, and one is the, like, your multimodal. So I'll say, like, multimodal is a different category, but I'll say, like, two types of offerings that a model can be. One is your online model offering, and one is the offline model offering. And what is the, like, and based on these two types of model, your infrastructure, your MLOps, and your deployment patterns will be really, like, different. So, for example, I'll give you a practical example. When I was working with the HBO Max, for example, think about, like, uh, uh, so you are watching a movie, and you will be, like, watching right now a movie, and you are, like, when you will stop it or pause it, and when you don't like this movie, what you're doing is you are going back to the homepage. And by the time when you go to the homepage, automatically it will showing some recommendation based on your history, that has which movies that you have searched, which movie you have liked it, or which movie you don't like it, or which movie recently you watched, right? And based on that, you will see on the homepage. And that is actually working on real time. So basically, we collect all your history, let's say logs, the watch logs, and all this, like, your activities logs. Then we take that as a feature that is called your features, and we pass that features into our recommendation model. And that recommendation model basically picks off the based on the feature, understanding the feature, it picks up, like, right set of, like, movies, recommended movies. And it takes, like, goes back to the a re-ranking model, another model that we use called a re-ranking model. The re-ranking model basically rank the, like, your movies, basically based on, like, different categories, different groups, and and push that into your homepage, right, your application layer. And that's where you see this. So this is very low latency, basically it is solved very real time. So you cannot, like, when you watch a movie, then when you don't like it, you go back to your homepage, you want immediately that movie need to be get, like, the recommendation should be there, right? So this is basically our model need to be very much, like, efficient, low latency, and that is called your online survey, where when your model is, like, on real time, we access it as an API, and we pass the input, and we want to get the response out of it very fast. Then it is called your online survey. The offline serving is kind of like, a different aspect. Offline serving is kind of like, uh, let for example, the offline serving is kind of, I'll give you a practical example. Let I'm building out a model, which is basically detects a predictive maintenance model basically. So I do have electrical mechanical devices, all these electrical mechanical devices that it has been equipped on a data center, that which is doing the cooling. It will be doing like, temperature checks. It will be doing like, water like, pumps. All these are electrical mechanical devices. And what I'll do is, I will end of the day, from the IoT sensor are there on this electrical, all this equipments, and they will be sending out the data about their like, the their performance, about their metrics of every day, how what exactly their health is. And I'll be taking this all this data, and I'll be in a, like, every day as night 12, when the like, traffic is lays, I'll be sending out the bunch of the data to my model, and my model will be reading like, on a uh, on an offline basis, and it will be take that data and it will predict out like, hey, this model, this based on this like, the feature set that we collected from this electrical device, it looks like the maintenance need to be in the next 10 days. If it is not, it could go to the like, it can break basically, right? So it basically it will be served offline. And for the offline serving, we don't like, in the resources that is employed, or the like, the container that we create, it is less, less complicated. Or you can say that you don't have to be resource efficient. It runs like, you need to be more focused towards like, accuracy of it. You don't have to put head in terms of like, how efficiently you can run that. No, sorry, how latency sensitive it is, not latency sensitive. So that's the like, two aspect to it when we deploy a model. So we need to understand like, what exactly the business is required, and based on that, we need to make sure that our environment, and when we deploy the model, that need to be very much like, whether it should be online or offline. I'll take a like, pause here. I'll go back to the Manik, and then just check like, time here. uh Hey Manik, are we good with the timing? So
Yeah, we are very good with the timings. To be honest, I've hosted a lot of sessions, and you're doing really great because I haven't seen speakers checking on the timing, seeing the agenda. I really appreciate that. Really appreciate that. Yeah, in the
okay,
meantime,
no
we have
problem.
a session tomorrow. If you want to take a couple of questions that are in the chat section, we can take that, and we can cover all the deeper or advanced topics for tomorrow. What do you say?
Yeah, we can pick like, the topics that I talked about today, right? The LLM search basically, right? So I can talk about more about like, the how exactly the embeddings works, and how exactly the search happens on the vector space, how the image embeddings happens, how the text embeddings happens. I can give you the practical example of it, and I can show you the demo of it. So would you mind to like, would you want to do that?
Yeah, yeah, we can do that. Do that because we still have 10 minutes, or there are a couple of questions too, maybe five or six. So what do you think? First of all, demo for 5 to 6 minutes, then questions. Is it fine?
No, we can take the questions now. Tomorrow we'll do the demo and all.
Okay, tomorrow we can do the demo. Cool. As the questions would be from the starting of the session. So there are some basic questions too, but yet essentials. So as that, so we have the question, sir, how much mathematics should we need to master for ML, machine learning?
Uh, okay. So can I see the sure, 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 sure. Okay, okay. The math is very much essential, right? Uh, if you can share, let me share my screen again. Uh, so okay, here you go. So, okay, cool. So what I learned is basically, you can see, right? Um, if you can see my screen, that is called your, I will share this like, already. I'll share with you. So basically, you can see some of the like, mathematical concepts. right? So like for example, vector, like your linear algebra space, basically what is this matrix is, what is your dot product is, right? You don't have to, you don't have to what I can say, there are lots of resources. It is basic math. It is very much like basic math, a 10th level or a school level maths, uh, which you have already read. It's not like very much difficult one. So to start with, I would say get an understanding of those maths basically. So basic math, basically what is exactly a function is, what is a vector is, what is a matrix, and what is the multiplication, how the vector multiplication happens, or sorry, matrix multiplication happens. All these are very much basic math that you need to learn. You don't have to start learning a complex math or something new. It is a school level math already you have read, that only you need to cover linear algebra. So there are a couple of good resources which you can follow and that I have learned. So basically the math record for the machine learning I can share as well. So that will be good enough. I hope I answered your question.
Okay,
Yeah.
wonderful. Nice. So the next question we have is from Huhu. She's asking, it was said that there are very few opportunities for the freshers in this field, particularly ML related, as compared to those who have done masters. So, like, is it true? Like, we have to do masters or like bachelor is enough for this field?
No, that's not, absolutely not true. Not true at all. Why I'm telling you. So in US, I'm talking about, because I've been here, I've been in the abroad for almost 8 years, or close to yeah, close to 8 or 9 years, right? Different countries, different. I moved to different countries. I worked with the different states in the US. So and one thing that I uh, noticed is on my team, I mostly get the bachelor engineers as trainee or as a intensive basically, right? They come to the do the intensive. And one thing that I learned from them, I never ashamed of saying it on this, because I learned from them. Why? Because they're very much they're that they have already done something which I have never explored it, right? So it's all about not, education is not a boundary at all, neither master neither bachelor. It's all about the effort that you are putting, your learning potentials that you have, part of your college, or you're putting out of extra time that you are putting, or the learning um interest that you have. There are plenty much of resources out there where you can learn machine learning, and that makes you a best fit for this job. It's not about a master or bachelor makes you best fit. The skills that you acquire, that makes you best fit. If you are in a bachelor, that doesn't or if you are a master, that doesn't qualify you to come to this field, right?
Okay.
So yeah, I would suggest yes, go for masters. That is the advanced level of things that you're doing, part of your career. That is good, but that's not a constraint for your pursuing to this machine learning. So I would suggest learn as much as projects, do the as much as projects that you can, join the hackathon groups basically, and try to solve some of the hackathon groups, some of the problems, basically machine learning problems on the hackathon group itself. Do the internship, and apply for the internship to a good companies where they're practically doing the machine learning, learn from it, right? So that will lead to a path of to this machine learning. You don't have to pursue it is not mandated to have a master degree basically.
Cool. Nice. I hope this answers your question, Kuhu. Now, we have the next question from Aditi Chaudhary. She is asking, how difficult is it to work outside India? Because you have so much experience of working outside India. So, any difficulties that you have faced at the initial level?
See, guys, I came from a very much like, I didn't pass out from a IIT or like, college. I pass out from a decent college. Okay. Like you guys. So, so this is very much like, what I face is there is no difference working in Bangalore or any of part of like, India, an IT company, or than in US. Maybe the cultural difference in terms of there should be there, but technically I don't feel work wise there is a difference. Wherever you
Okay,
go, I can say that in outside of the like, India is having lots of opportunity right now, and many companies out there, they're like, shipping out good products, they're building out good products. And similar to here, this is a very much fast paced, right, environment. And and same as India as well, I don't see in it like, huge differences there. And practically my perspective is no difference, right? There is no difference at all. As long as you come to outside of like, outside India, it is same as like, once you will like, feel some anxiety for a couple of like, months, but you will, after that you will feel like, it is same. There's
cool.
no difference.
Nice. I hope that answer your question, Aditi. We have next question from Kuho again, and we'll cover two questions simultaneously because those questions are same. How should a fresher start with this field? Like what kind of projects we need to have in our resume, particularly, and how much it's needed to know before applying to any internship or project. Similar question is from Anshika. How freshers can make resume, particularly for ML developer? So yes, we can club these questions and can answer them.
Very good question. Okay, I would say this way. uh as I mentioned like, earlier, um one thing that makes you stand out is get involved as much as you possible in terms of the hackathon groups, right? Do the hackathons, try to win those hackathons, right? Get involved in terms of like, different open source ML projects, right? You could go to the GitHub and you will find out like, lots of open source ML projects where people are contributing. Start contributing to those open source GitHub projects and enroll like, to the hackathon groups. Those like, plenty of this. I can share you the resources where you can start with. And in addition to that, the another best way to learn is create a like, close group or the similar mindset of people in your college, right? It could be from the different stream, it could be like, from your batchment, or your seniors, doesn't matter. Pick up a like, machine learning problem on around you, on your college, or your like, some of the practical problems that you are facing on your college, right? For example, like, your students like, enrolling system are not good, or you want to add some machine learning features to it, right? Or you want to do some fun projects in terms of like, you do have a event coming off your like, tech fest is coming off your college, and you want to create a fun thing. Basically, someone will be uploading a image of them, and you will be adding a badge to automatically, or detecting their like, based on the face. You will be like, giving them the identity, like, identity card automatically. All this like, fun projects that you can do, right? So pick up a project and start like, working on those, right? If you are not able to like, create a group inside of your college, then I would say join the hackathon groups. And there are plenty of hackathons going on every month, like, 100 of hackathon groups that are going across the globe. So you can join any of them sitting at your home, and you start like, contributing. Even though you don't know
Definitely.
anything about the machine learning, you go and write the document at all. You be the part of the hackathon, write a set up like, only document itself. And that I have done. So then you at least you can start learning from that, right? You will come out of that fear zone basically, right? And then the next step will be contributing to the GitHub, like, open
Yeah.
source projects that will make you a lot. So I would say like, that's the best way. And coming back to the resume, Resume is something like, you don't have any practical experience, but the resume will stand out if you will be adding some of the, like, I have contributed to this GitHub, I've contributed to this, like, I have taken, like, this hackathon groups that I have contributed, and I have get this position and acquired this skill. That will actually will make and stand out, make your resume stand out, and it will allow to, like, the companies will hire you for the internship. And the internship basically, um, yes, as an internship, I would say, like, yes, we look like, a little bit of, like, the skill set that already the student is having. If you are having already, like, already attended a couple of hackathons, you have contributed to some GitHubs already, if that credential on your resume, definitely you are a good candidate for that, right? Just remember this. If you're going back with, like, hey, I'm just, from this college and I have done this Python course, this Java course, this machine learning course, maybe that's a not enough for you, right? So you need to show some credentials, like, activities around it. Just doing a course itself is not sufficient. That's my
Definitely.
recommendations.
Lovely. I hope that answers your question. Now we have again the question from Anshika. I guess Anshika is really curious. It's good to see Anshika.
Yeah,
Curiosity is
sure.
the thing which will made you thrive in the coming years. So she is asking: is necessary to remember all the model of code or only working concept for job purposes? Hmm,
Okay, so that's the very much, like, vast question, because the data science or the machine learning field is very much like, it's not a, it's a multi-dimensional field, right? There are lots of roles, responsibility there. It depends on which route that you are going, right? Whether you are a research scientist, you are a data scientist, you are a machine learning engineer, ML ops engineer, right? Is a data engineer. What is the scope of your job? Which direction that you are going? It depends on that, right? As a ML ops engineer, or maybe you don't have to know all the concepts of, like, you need to know the concept, but not exactly the integrity of how the model has been developed. You need to know more about, like, productionizing those models, right? Understanding, like, your how exactly, what is the architecture of the model that will help you, and the evaluation steps, and you will be more concentrating on, like, how I can serve that model, right? Whether it's a batch inferencing or the real-time inferencing, how I can, like, help my data scientists to navigate with, like, a automated fashion of training it or evaluating it. So that scope will be, like, limiting your knowing, like, very details about the model architecture and all. And when you go to a data scientist, or similar, like, ML engineer, you need to know a little, like, deeper of it. Or a research scientist, if you're going, then you know more deeper of it, right? So it depends on the job function, which, like, dimension that you are going. Based on that, the scope of your job will change.
lovely. I hope that answers your question, Anshika. And we have the next question from Aditi Chaudhary. On what criteria to decide which technique we should use in feature engineering and when?
Okay, the feature engineering, as I mentioned, is the where I spend 70% of my time. It's a very broad question, right? Um, I will not able to, like, I'd say, like, it need a session for that, but I would say that, in a very short way, I can say that the feature engineering depends, like, which techniques that you are using, or which, like, kind of, like, feature engineering, it depends on, like, what prompt that you are solving, or which modality that you are working on. If you are working on a supervised model, or a, like, a traditional model, basically a classification or regression model, then there are, like, out of there, you do have a basic set of, like, features engineering that you will do. If you're doing a multimodality, basically image, or you are working on voice, or you are working on, like, your video, audio, all these things, basically, or a text. So unstructured text, basically, if that is the case, like, definitely that feature engineering is really different, right? So That's why, like, the technique is depends on, like, which kind of, like, model you are training. And you can
Yeah,
come with, like, next, you can post your, like, which exactly, which kind of, like, problem that you are trying to solve. And I can suggest you, like, best feature engineering steps that you should follow, basically.
cool. I hope that answers your question, Aditi. We have a last question from Shreya. First of all, Shreya is thanking you. Hi, the session was great. Thank you for the opportunity. Thank you so much, sir. And what would you suggest to stand out in terms of ML pipelines in projects?
What suggest you stand out in the terms of, would you mind to rephrase the question, please? What it, like, stand out in terms of what exactly you want to, like, want to.
And maybe Shreya, if you are here live, you can rephrase the question, like explaining it a bit, if you can. Otherwise, we can cover this question tomorrow as well. Okay, we have a class tomorrow. And with this, we can wrap up the session. But before that, there's a vote of thanks. Aditi is thanking you. Sir, Anshika is thanking you. Thanks for the resource. Thank you so much. Thank you so much, sir, for the guidance. Thanks, sir. And thank you so much, Surinder sir, for this wonderful session. We are so much excited to meet you again tomorrow with deeper and more complex concepts of machine learning. And we'll
Yep.
together explore the world of machine learning and simplify it to our audience. Thank you so much and
Yeah,
have a lovely day.
absolutely. Yeah, thank you.
Thank you so much, audience, for watching and for tuning. Anshika, if you are joining the session, I'm very happy to let you know that you have been active from the starting, and we would like to gift you something, maybe a small gift. You can DM me on WhatsApp. And yes, thank you so much, everyone, for joining, and meet you tomorrow. Have a nice day. Bye bye.